Unveiling the mystery. What is dark matter? Imagine a cosmic puzzle. A riddle that has scientists scratching their heads. That's dark matter for you. It's invisible, it's mysterious, and it's everywhere. But what exactly is it? Let's break it down in simple terms. Dark matter is stuff we can't see. It doesn't emit light, it doesn't absorb light. It's like a cosmic ninja, invisible but powerful. We know it's there because of its effects on things we can see. Scientists think dark matter makes up about 85% of all matter in the universe. It's called dark not because it's evil, but because it doesn't interact with light. In the next sections, we'll explore these clues and see why many scientists believe dark matter is very real indeed.
The Cosmic Detective Story, Evidence for Dark Matter. Let's put on our detective hats. We're looking for evidence of dark matter. Our first clue comes from galaxies. They're spinning too fast. According to the laws of physics, they should fly apart, but they don't. Something invisible is holding them together. That something could be dark matter.
Next clue, gravitational lensing. Massive objects bend light. We see this bending around galaxies, but the bending is stronger than it should be based on the visible matter. Again, dark matter could explain this.
Then there's the cosmic microwave background. The pattern we see matches what we'd expect if dark matter exists.
Lastly, we have computer simulations. These models only work if dark matter is included. Without it, the simulated universe doesn't match what we observe.
Hunting the invisible methods to study dark matter. How do you study something you can't see? It's a challenge, but scientists are up for it. They use a variety of methods to hunt for dark matter. Let's explore some of these techniques.
One method is called indirect detection. Scientists look for particles produced when dark matter particles collide and annihilate each other. These collisions might produce gamma rays or neutrinos. We can detect these with special instruments.
Another approach is direct detection. Scientists build detectors deep underground. They hope dark matter particles will collide with normal matter in these detectors.
Particle accelerators offer another way to study dark matter. Scientists smash particles together at high speeds. They hope to create dark matter particles in these collisions.
Lastly, there's the astronomical approach. Scientists study the motions of stars and galaxies. They look for the gravitational effects of dark matter.
The mathematical dance equations and dark matter. Mathematics is the language of the universe. It's no surprise that it plays a crucial role in dark matter research. Let's dive into how equations help us understand this invisible substance. First, there's Newton's law of gravity. It describes how objects attract each other. But when applied to galaxies, something doesn't add up. The visible matter isn't enough to explain their behavior. Mathematicians had to modify the equations to account for dark matter. Then we have Einstein's theory of general relativity. It describes how mass warps space-time. This theory is crucial for understanding gravitational lensing. Mathematicians use complex equations to model how dark matter bends light. Statistical analysis is another powerful tool. Scientists collect vast amounts of data from telescopes and detectors. They use advanced statistical methods to sift through this data. Lastly, there's computational modeling.
Section 5. The elusive discovery. Has dark matter been found? The million-dollar question, has dark matter been officially discovered?
The short answer is no, not yet. But that doesn't mean we haven't made progress. Let's look at where we stand in this cosmic treasure hunt.
Several experiments have claimed to detect dark matter. In 2008, the Dama Libra experiment in Italy reported a possible signal, but other experiments couldn't confirm it. It's like hearing a whisper in a noisy room. You're not sure if it's real or just your imagination.
In 2016, the Xenon 1T experiment in Italy made headlines. It's the most sensitive dark matter detector ever built. It hasn't found dark matter yet, but it has ruled out many possibilities.
More recently, in 2023, researchers using the Hubble Space Telescope made an intriguing discovery. They found that dwarf galaxies in the Fornax cluster are behaving oddly. Their movement suggests the presence of dark matter.
Section 6. Voices from the Scientific Frontier. Opinions on dark matter. The scientific community is buzzing with opinions about dark matter. Let's tune into some of these voices. Remember, disagreement is a healthy part of science. It drives progress and encourages new ideas.
Many scientists firmly believe in dark matter. Astrophysicist Vera Rubin, whose work provided strong evidence for dark matter, once said, "In a spiral galaxy, the ratio of dark to light matter is about a factor of 10. That's probably a good number for the ratio of our ignorance to knowledge. It's a humbling perspective on how much we still have to learn."
On the other hand, some scientists propose alternative theories. Physicist Mordechai Milgram developed modified Newtonian dynamics, or MOND. This theory suggests that gravity behaves differently on galactic scales. It could explain galaxy rotation without dark matter.
Then there are those who sit somewhere in the middle. Physicist Lisa Randall says, "I think dark matter exists, but we don't know what it is. We don't know how it interacts. We don't know when it was made. We don't know how it was made. We don't know where it is."
Section 7. Beyond the visible dark matter's role in the universe. Dark matter isn't just a cosmic curiosity, it plays a crucial role in shaping our universe. Let's explore how this invisible substance influences the cosmos we see.
First, dark matter is the cosmic architect. It forms the scaffolding of the universe. Normal matter follows this scaffolding, forming galaxies and galaxy clusters. Without dark matter, the universe would look very different.
Dark matter also affects the evolution of galaxies. It helps galaxies grow by attracting normal matter. It's like a cosmic magnet, pulling in gas and dust. This process is crucial for star formation. Without dark matter, we might not have the beautiful spiral galaxies we see today.
On an even larger scale, dark matter shapes the cosmic web. This is the largest structure in the universe. It's a network of dark matter filaments, with galaxies clustered along these filaments.
Section 8. Technological advancements, tools in the dark matter quest. The hunt for dark matter is driving technological innovation. Scientists are developing cutting-edge tools to detect this elusive substance. Let's look at some of these amazing technologies.
One exciting development is the use of quantum sensors. These ultra-sensitive devices can detect tiny gravitational effects. They might be able to spot the influence of dark matter particles.
Another promising technology is cryogenic detectors. These are cooled to near absolute zero. At these temperatures, even the slightest energy from a dark matter particle could be detected.
Machine learning is also playing a big role. Scientists use artificial intelligence to sift through enormous amounts of data. These algorithms can spot patterns that humans might miss.
Lastly, there are plans for space-based detectors. Section 9. The ripple effect, dark matter's influence on cosmology. Dark matter doesn't just affect galaxies. It has a ripple effect across all of cosmology. Let's explore how this mysterious substance influences our understanding of the entire universe. Dark matter plays a crucial role in the formation of cosmic structure. In the early universe, it clumped together under its own gravity. This created a cosmic web that guided the formation of galaxies. Without dark matter, the universe would be a very different place. The concept of dark matter has also changed our view of the universe's composition. We now believe that ordinary matter, the stuff we can see, makes up only about 5% of the universe. Dark matter accounts for about 27%, with the rest being dark energy. It's a humbling realization. Most of the universe is invisible to us. Dark matter also influences our understanding of the universe's future. Its gravitational pull works against the expansion of the universe. The balance between dark matter and dark energy will determine whether the universe will expand forever or eventually collapse.
Section 10. The Road Ahead. Future of Dark Matter Research. The quest to understand dark matter is far from over. It's an exciting time in science, with new discoveries on the horizon. Let's look at what the future might hold for dark matter research.
One promising avenue is the development of new detectors. Scientists are working on even more sensitive instruments. These might be able to directly detect dark matter particles.
Another exciting prospect is the use of gravitational waves. These ripples in space-time might carry information about dark matter. Scientists are developing new ways to detect and interpret these waves.
Advances in computer simulations will also play a crucial role. As computers become more powerful, we can create more detailed models of the universe. These models can help us understand how dark matter behaves on cosmic scales.
Lastly, there's the possibility of surprising discoveries. The next big discovery could be just around the corner.